Next, I want to talk about some of the physical structure of the atmosphere. And so here we have the atmosphere divided into different layers. Um, you can divide it in different ways, but here we've divided it by how temperatures change as we go upward. The bottom layer being what's called the troposphere. This is where really most, if not all of the weather is really at this bottom layer. And then above that, we have the stratosphere, where this is kind of above the weather. This is where a lot of jets fly over. If you've ever flown in a jet, you might go up through clouds, and you're out of the clouds. You're kind of above the weather in the stratosphere. And then we have other layers called the mesosphere and thermosphere. That's getting out into space. But we're really going to focus on the bottom layer. The reason why we can divide it this way is the way temperature patterns change. So if the line is moving to the left, it's getting colder. If the line is moving to the right, it's getting warmer. So here, we're at the surface, and if we were to start moving upward in a kind of like, let's say in a jetpack, right? As we move up, the temperature would be dropping. It's going to be colder as we move up into the troposphere. Now, when we get into the stratosphere, it's going to reverse. It's actually going to be getting warmer. And then when we get past that, it's actually going to switch again. Now, one thing I should note is that here in the bottom, most of this is not really related to the warming of the sun. It's because it's really the way that the atmosphere is warmed. But that being said, the pattern is it gets colder. In the stratosphere, it's getting warmer. And that's going to be a really important concept. So let's kind of just highlight that one more time. At the very bottom, we have the troposphere. And the one thing that's true about the troposphere is that as you go up in the troposphere, it gets colder. That's an important principle that we have to understand why we have cloud formation and rainfall, is that change in temperature as you go up in the troposphere. Now, this is where really the action is. We're just about anything we focus on in this class is going to be limited to that troposphere. Now, just to give you some contrast, it changes when you get to the stratosphere. Here, it's actually warming. And because of that change, clouds will rise really to the top of the troposphere. And then they'll be stuck there. Because of that difference in temperature, they won't rise past that. So our weather is really limited to this bottom layer called the troposphere. We won't even really worry about the layers above that. Troposphere is going to be the most important. Now, one thing I will mention before we go on is be aware of the metric system for temperature, Celsius. So we have Fahrenheit, just to kind of show you the endpoints. If in Fahrenheit, water boils at 212 degrees. In Celsius, it's more simplified. It boils at 100 degrees. In Fahrenheit, water freezes about 32 degrees. And in Celsius, it's at 0 degrees. So it's a different temperature scale. And we're going to be using that a lot to describe temperature patterns. So read about that, be aware of that. Just know that it's a little bit different than the temperatures we may be used to talking about. Okay. So this is a closer graph showing changes in altitude in miles or kilometers, and also changes in temperature. Here it's getting colder, and it's getting colder at a specific rate. It's getting colder at 6.4 degrees Celsius per kilometer. Or you could convert that and talk about it in feet. But we're going to talk about it in Celsius and kilometers because it's actually simpler that way. And so, generally speaking, this change in temperature with altitude is called a lapse rate. We're going to be talking about different kinds of lapse rates, and a couple right now and a couple later on. So the temperature usually gets colder. You can have weird situations where warm air is on top of cold air or vice versa, but let's just say for practical purposes now, as you go up, temperatures go down. That's an inverse relationship, and that's called the lapse rate. And here on this figure, it's labeled the environmental lapse rate. And that's the real lapse rate for any given location. That everywhere on the Earth, the environmental lapse rate, the real lapse rate is going to be slightly different. Now, but typically what we do is we look at the average, also called the normal lapse rate. And what that is, it's the average for the Earth as a whole. Now, everywhere is going to vary slightly from this. That'll be their environmental lapse rate. But the average is 6.5 degrees Celsius for every 1,000 years. Also, note that 1,000 meters is also 1 kilometer. So the normal or average lapse rate is 6.5 degrees Celsius for every kilometer or 1,000 meters, what have you. But it's going to vary a little bit depending on where you live. By the way, that's also 18 point something degrees Fahrenheit per mile, if you want to think about it that way. So we'll likely have some type of kind of activity where we're going to look at lapse rates and do a little problem solving with it. But so note that number, 6.5 degrees Celsius per kilometer.